So, good evening, everyone. Thank you for joining us in today's session. I want to let you know that today we are continuing the SEACAP for SDG training session that are dedicated to the selected reference projects. And today we have with us representatives from the Sustainable Cities project to present us with selected outcomes that are going to be used as part of the toolkit for the SEACAP for SDG project. As you know, we have available the outcomes fact sheets. I want to state at this time that there are some changes to the fact sheet, and in the next few days, it has been updated, but we need to have the formal approval to be available to all of you. So after the session, along with material, you will be also receiving the updated fact sheet to let you know, to get a few more details about the project and the selected outcome. Today with us, we have with us Mr. Andrea Moro to present us as part of Sustainable Cities project. The online platform enables municipalities to generate contextualized tools for any city, as well as the decision-making methodology to be adopted when applying the tools. So thanks, I think, to everyone that has joined us today. And I'm giving the floor to Mr. Andrea Moro to show us his presentation and discuss with us this interesting topic on what has been done on the Sustainable Cities project. Thank you very much. So, Mr. Andrea Moro, the floor is yours.
Thank you very much. It's a pleasure to be with you, to have the possibility to introduce the main outcomes of our project, Sustainable Med Cities. Sustainable Med Cities is a capitalization project of an Interreg project that was carried out in the previous program named SESBA Med Sustainable Cities. In practice, in the new project, in the SCBC Med project, we are upgrading, upscaling, updating the SESBA Med assessment system to be usable in the whole Mediterranean region. Today, what I'm going to do is to introduce you to the assessment system, and also to explain the decision-making model we have developed that is based on the assessment system. And the decision-making model is aimed to support the municipality in the identification of the best sustainable retrofit concept to improve the quality at urban scale, at the building scale, or building and neighborhood, of course. So the first part of the presentation will be about the assessment tools. I will also show you the web tool we have developed. It is still a beta version. We are going to release the first operational version that you can use and test in your project. And in the second part, I'm going to explain the use of those assessment tools in a decision-making process. So I'm going to share my screen. So basically, we have developed an assessment system that is useful to measure, to score the sustainability at different spatial scales, at building scale, at urban scale, intending the neighborhood or small urban scale like a cluster or block, and also at whole city scale. The methodology used in our assessment system has not been developed in the Sustainable Med Cities project, neither in the previous SESBA Med project. It is coming from a global, it was not only European, I mean with global world level, research process that was launched in 1998, named Green Building Challenge. And the scope, the objective of this research process was to define an open source transnational methodology a sort of common language for measuring the sustainability of the built environment, starting from the building scale. A methodology based on the principle of contextualization. Basically, let's say that this is an approach different from maybe the most well-known transnational systems like BREEAM or LEED or others that tend to use the same system with little contextualizations everywhere. The main assumption here is that you must use local tools, locally contextualized tools for measuring the sustainability of buildings, neighborhoods, and cities, because each region can be more or less advanced, and we can have different, really different conditions, starting from the climate, of different building practices, and so on. So the idea here was to define a common methodology, but useful to define locally contextualized tools that, being based on the same methodology, are harmonized. The first tool developed following this approach historically was the SB tool, the Sustainable Building tool. And the process, this Green Building Challenge process, was led by a transnational no-profit organization named ISB, that stands for International Initiative for a Sustainable Built Environment. We are ISB Italia, we are the Italian chapter, and we were member of the Selva Med project, and actually we are partner of the Sustainable Med Cities project. So what is the idea? As I told you, the idea is to cooperate transnationally to define a common generic assessment system named generic framework in our terminology. And this generic multi-criteria assessment system is not operational. To use it, to carry out an assessment, you need to contextualize the generic framework to create a local tool that can be national, regional, municipal, it doesn't matter. So you need to take the generic framework and to adapt it to your local context. So the principle is we start from a common basis. For instance, the Sustainable Building tool global, and through the contextualization, you can create local versions. This kind of tool, generic framework, has been the origin of several assessment systems used in Europe. For instance, the Italian public assessment system for buildings, named Protocollo Itaca, is the adaptation of SB tool to Italy. And today it is also a national standard. It is a UNI standard. UNI is the Italian standardization body. We have also a Spanish version that is named Verde, coming from the same root. We have a version in the Czech Republic. We have a version in Portugal. There was also a version in Austria, for instance, and in other places. I told you it was a global approach, a global research process. For instance, the national Japanese assessment system, CASB, is based on SB2, is a cousin of those ones. So you start from the generic framework, and to create your specific tool, you have to carry out a contextualization process. So basically, the contextualization process can be reduced to three main steps. First of all, you select from the generic framework the assessment criteria that you want to apply locally. The generic frameworks contains also 200 to 150 criteria and relative indicators. And you will never use all of them in your tool. So the first step is to select the ones that are the most significant in relation to your context. And usually an assessment tool is composed by 40, 50 criteria maximum. If the tool is too wide, too big, in terms of number of criteria, you risk to have a system not really manageable. One time that you have selected the criteria, you are going to define the performance scale. Basically, SB tool, for instance, it is a rating tool. So at the end of the assessment process, the building receives a score ranging from -1 up to +5. And the score represents how is performing the building and how better the building is in relation to the local context. A building taking 0 is the minimum acceptable performance in relation to the context. If a building takes an higher score, it means that it's better. And but the scales, the performance scales, are defined in relation to the local situation. So you will go to define what is the value of the indicator, criterion by criterion, that corresponds to a level 0, and what is the level of the indicators that is corresponding to higher scores. To make you an example, to make it more understandable, we had other experience in other European projects in this field. And some years ago, we were working in an alpine space project, defining a tool for assessing the performance of alpine buildings. And one of the partners was the regional authority of Vorarlberg. Vorarlberg is a very advanced region in Austria in the field of energy performance. And we were defining a rating tool also in this case, based on another methodology in any case. And so we had to decide the benchmarks. So what were the minimum acceptable performance to get a certain score using the system? For them, the standard practice was passive house, not for Italy. For Italy, passive house is the best performance. So in the case we were using Austrian benchmarks, all the Italian buildings were performing very bad. In the case we were using the Italian benchmarks, all the Austrian buildings would be exceptional. So you see here that it's not possible to use the same benchmarks in two different regions, because what you want to do is to measure the performance of a building, neighborhood, city in relation to the local context, and to implement actions to improve the sustainability in relation to the local context. And more or less the same approach is applicable to the topic of weight. Criteria can have a different weight in relation to the different contexts. For instance, water consumption can have a higher value in South Europe, where maybe the water resource is more scarce, and maybe water will have a less weight in Northern Europe, where maybe water is not really an issue. So the contextualization process is really the adaptation of the generic framework to your local situation, so that you will get, for instance, SB2 Italy, Austria, France, or whatever. You can also do a more specific adaptation. You can adapt the tool to a regional context. For instance, in Italy, we have sub-versions of Protocollo Itaca. So we have a national, let's say, reference version, and then each region in Italy develop its own version, changing the weights, changing maybe the benchmarks to adapt the tool to the specific priorities, local priorities. The final result using those tools is a set of scores. The scores are a sort of evaluation about the level of sustainability. And we have an overall final score, always from -1 up to 5, but we have a series of sub-scores that allows to understand the performance of the building in relation to specific topics, water, energy, materials, use of site, impact on site, social issues, economic issues, and so on. So this methodology has been tested in hundreds of case studies over time, starting from the late 90s. It has been really it is a real transnational methodology, because coming from the cooperation of more than 25 countries. Here you see a list of countries participating in the process, and the names of the organizations are the coordinators of the local working groups. So you see ministries, universities, agencies, and so on. And over time, the system has been tested in different countries, and also this methodology contributed in the development of other rating systems, like in US with LEED, or in France with HV, etc. So it has been tested in really many different situations, many different kind of buildings. So I'm projecting here some slides that are, let's say, case studies produced over time in the context of the Green Building Challenge process. It's a very flexible system, because you can use the system on a skyscraper, but you can adapt the system more simple, of course, on a small passive house. This flexibility is one probably of the best aspects. This is the national Japanese assessment system, based on the same approach, CASB, and so on. So how does it work, this methodology? Basically, a generic framework, and we have produced in Sustainable Met Cities 3 generic frameworks, one at building scale, SB tool, one for neighborhoods, SN tools, Sustainable Neighborhoods tool, and one for cities, SC tool, Sustainable Cities tools. So each of those generic frameworks has a modular structure. So the criteria, the assessment criteria, are grouped under different issues, and the issues are usually coded with a letter, A, B, C, D, etc. And issues represent general topics that are relevant when you are assessing the sustainability of the built environment. Each issue, so each module, A, B, C, D, contains categories. In the categories, we have criteria, and each criterion is connected with an indicator. The indicator is what you are going to measure for assessing the performance of the building, neighborhood, or cities. For instance, a criterion could be daylighting, and the indicator could be the daylighting factor. So the ratio between the quantity of natural light you have inside the building and outside. Or another criterion could be permeability of land, and the indicator is the share of the land that is permeable on the total area of the land, and so on. So this is a visualization of the hierarchic levels. You have an issue, you have several categories. Categories contain criteria, and criteria are all linked with an indicator. In the building scale tool, we have 8 issues. You can see them in the table, dealing with the site, the energy, the environmental loading, the environmental quality, service quality, social, economic aspects, cost, and economic aspect, adaptation to climate change. So each of the 8 issues contain different categories. And the different categories contain criteria. In total, there are 80 criteria in the building scale tool, and 17 key performance indicators. What are the key performance indicators? I told before that when you are producing your local version, you will select, for instance, the criteria among the 80 in SB tool, if we are producing an SB tool for a specific region. But of the 80s, 17 are mandatory. So you must include them in your local version. This is because those 17 are significant, they are relevant for any context, and they are the ones linked to the global common challenges like the SDGs, the Sustainable Development Goals, or the carbon reduction goals, and so on. So they are surely relevant in any context. Then you can add as many you want. 17 is the minimum number of criteria in a tool. The SN tool, the neighborhood scale tool, has in total more criteria. They are 133, 10 issues, 43 categories, 14 KPIs. Of course, we are in a higher spatial scale, and of course, the number of topics, themes is larger than the building, the simple building scale. And then we have the city scale tool. Here we have 10 issues, 99 criteria, and 10 key performance indicators. And this is another representation of the structure. So you can see here an issue with the categories A1, A2, A3, and inside the categories you can look at the criteria. And this is also the coding system. The letter is a category, letter plus a number, a letter is an issue. A letter plus a number is a category. A letter plus a number dot another number, like E1.1, is a criteria. And here you have an example of indicators. So each criterion is a name, and each criterion is associated to an indicator. And of course, the indicators, they have a unit of measure. Not all the indicators are quantitative. Some indicators are qualitative. In the case, it is not possible to measure the performance using a physical quantity, but the number of qualitative criteria is really very limited. And this is how the indicator is described in the generic framework. There is a publication for each of the different generic frameworks, SB2, Lesson 2, Lesson 2, that is describing each criterion in terms of intent. So what is the justification behind this indicator? What is the indicator? What is the unit of measure? An assessment method, a standard or a reference. So you can, many criteria are connect to European on ISO standards. The key performance indicators, they are described much more in detail because we want to be sure that each assessment is evaluating the key performance indicator using exactly the same calculation procedure. So to maximize the comparability of the values among buildings, neighborhoods, and cities in different regions. So as I told you, the first step in the contextualization process is the selection of criteria. This happens for the SB tool, Lesson tool, or SC tool. The KPIs are mandatory. The recommended number of criteria is about 40, 50. Among them, the key performance indicators. So the principle is to have the cities for defining their own SB tool, Lesson tool, or SC tool, but keeping, it is the red dot, a common core of indicators, the key performance indicators. So how works the assessment process? Basically, we have three steps to get the final score. So assuming that now you have an SB tool or SN tool or SE tool, the process is the same, that has been contextualized. Now you have, for instance, to evaluate a building with SB tool or a neighborhood with SN tool or a city with SC tool. So the first step that you are going to take is the characterization. Basically, you will calculate the value of the indicators. For instance, if I'm going back to this table. For instance, if total water consumption is one indicator in your local SN tool, you are going to apply the calculation steps, and you are going to calculate the liter per day per occupant, that is the mean water consumption in the neighborhood. And the same you could do with, for instance, the concentration of PM10 or the final thermal energy consumption for building operation. You are going to calculate those values. So the values of each indicator that has been included in your tool. And at the end of this process, you will have a set of numerical values. You will have kilowatt hours, you will have cube meters of water, so you will have kilograms of CO2. So you will have a set of numerical values with different, of course, unit of measures. Like in this case, you have 3 different criteria with, of course, their indicators, and the final result is a percentage, days per years, kilowatt hour per square meter per year. So depending on how many indicators you decided to include in your tool, you will have a set of minimum, the number of KPIs, maximum what you decided, you will have a set of values. And
Andrea, can you hear us?
these are,
Yeah.
okay, do you hear me now?
Yes, now we can hear you. We had some issues. We couldn't hear you for a little bit.
Yes, sorry, because it could happen again. Don't worry, because we just moved office this morning, and we have some little troubles for the connection. So probably
It's okay. I was just worried maybe it was my connection. So yes, of course you can continue.
it is mine. It is mine, but
Okay.
it could happen. So don't worry. I will be back in a few seconds.
Okay, perfect.
Okay, so this is a graphical representation of some indicators assessed at urban scale. This is, for instance, the connectivity of the street network. It is the number of interconnections per square kilometer. Higher this number, more easy is to use a bike or to walk. The city in the world with the higher value is Venice, for instance, in Italy. Or could be this is the proximity of transportation or stops, or this is, for instance, the value of the albedo, the mean value of the albedo in a urban area. So this is something linked to the heat island effect. These are a representation of the mean consumption for primary energy for heating in the urban area. These are the CO2 emissions. Again, darker the color, worse is the performance for the different buildings. We can have also economic indicators and so on. So after the first step, we have a set of values. Now it's clear that we are talking about multi-criteria assessment system. So it means that we must combine the values of the single indicators to have a global evaluation. So the next step is normalization. It means that we are going in this step to associate a score to the value of the single indicators. And the score is ranging between -1 +5, as I told before. So what we are going to do is to, let's say, rescaling in this interval, -1 +5, all the different indicators, associating a score, so eliminating the unit of measure. And so we use normalization functions to do it. And we have different kind of normalization functions. Basically, high is better or low is better. Higher the value is better. For instance, the permeability of land, or low is better. For instance, could be the CO2 emissions. So it depends on the kind of indicator. This is the meaning of the scores. So 0 is the minimum acceptable performance. 3 is the best practice, and -1 is a negative performance. 5 is an ideal, excellent performance. And so when you carried out the contextualization of the tool, as told before, you, for instance, define criterion per criterion, what is the value of the indicator corresponding to the minimum performance, and what is the value of the indicator corresponding to the ideal performance, so score 0, score 5. And this is something that is done locally, because the minimum acceptable performance is defined in relation to your local laws, regulations, technical standards, maybe statistical data, or maybe scientific literature, simulation, and so on. So this is, let's say, a very important part of the process, where you are setting the performance scale. Because at the end, the score that you will achieve at the end of the assessment is what is the performance of your building or neighborhood or city in relation to the minimum local acceptable performance. And as I told before, we have 3 different normalization functions. High is better, lower is better, but we also have a qualitative normalization function in reality is applicable to the qualitative indicators. So this is, for instance, the representation of the higher is better normalization function, where you have basically on the horizontal axis, you have the indicator's value here, and on the vertical axis, you have the score, -1, 0, 1, 2, 3, 4, 5. So when you are defining the scoring scale for an indicator, you just say, this value of the indicator corresponds to 0, this value of the indicator corresponds to 5, and so you have a linear normalization function. And in the moment, you will calculate the value of the specific indicator, you, through a simple interpolation, you will get the score. So you will simply, using this normalization function, you will associate the score to the value of the indicators. If the value of the indicators is worse than the level 0, you get a -1. If the value of the indicators is better, in any case, you will have a flat function here, so you will get 5 points. It's not possible to take more than 5 points. This is an example with the connectivity of the street network that I showed before, where you have, for instance, the level 0, the minimum acceptable is 50 intersection per kilometer. The optimum is 180. This is the typical number of intersections in the center of a mid-age town in Europe that is pedestrian, usually. So in the moment, for instance, you calculate in the first phase 90 as the number of intersections per square kilometers in your urban area, you get a score that is 1.5. This kind of normalizations are done automatically by a software, as I will show you later. This is the lower is better function. In this case, it is the opposite as before. So you are going to define a value for the score 0 and the value that is lower for the score 5. So again, you have a linear function. And this could be, for instance, the case for the energy consumptions. If, for instance, the indicator is the energy consumption of the building or the neighborhood in relation with the maximum allowed consumption, and this is usually defined by an energy regulation, you can have a situation like this one. 0 is 100 because the minimum acceptable performance is that you consume the maximum allowed. And maybe you decide that 5 is the 25%. So if you consume less than the 25% or the 25%, you get 5. In the case, for instance, in your evaluation, the indicator's value is 60. Through the interpolation, you are able to calculate the score. And this is the case for the qualitative indicators. Qualitative indicators are described in terms of scenarios. And so basically you have just to identify which is the scenario that better fit your situation, and you assign the corresponding score. This is much more, let's say, less objective than a quantitative evaluation with indicators, so that we try to minimize the number of qualitative criteria in the frameworks. And finally, you have the aggregation phase, third step. So first we have calculated the value of the indicators, characterization. Then we have normalized the value of the indicators, and we have now a set of scores. And now it's time to aggregate the scores to produce the final score, so the final evaluation. And this happens through weighted sums. So here we have a new element coming in the game, the weights. So in this phase, assigning the weight, it will be possible to aggregate step by step the different criteria. The aggregation takes place in, let's say, 3 phases. First of all, you aggregate the criteria to determine the score of the category. Then you are aggregating the scores of the categories to get the score of issues. And finally, you aggregate the issues, and then you are able to calculate the final global score. So this is in principle how it works. For instance, in this example, we have a category B5 land that includes 7 criteria, B31, B32, 33, etc. In the normalization phase, we have defined a score for each of them. So for instance, B31 could be a 1.5 score, 3.2 could be 2.4, etc. So now it's time to calculate the score of B5. And the score is a simple weighted sum. So it is the score of B31 times its weight. So times 0.26 if the weight is 26%, plus the score of B32 times 0.11 if 11% is the weight, and so on. When we have done this aggregation, weighted sum up to B3.7, we have the score of the category B5. We have done the same for the other categories, so that each category has a weight, and then aggregating the scores, we'll have the score of B, results. It is an issue. And in the same way, we'll have the score of A, C, D, and E. Each issue has a weight, and aggregating the score, we get the final one. Of course, the weight are a very important element in this multi-criteria system, and we try to define also an objective process to assign the weight. starting from the weight of criteria. So for instance, the weight of B31, B32, B33, so 26%, 11.6. Starting from this level, how does it work, the system? Basically, we assume that each criterion in the system is correlated to an impact that has a certain intensity, extent, duration, and can be adjusted to local priorities. For instance, if we have a criterion that is the CO2 emissions, this is something that has a very wide extent. This is global. The CO2 emissions don't stay over your building or your city. They are contributing to the global warming effect at world scale. The duration of this effect can be very long, and the intensity can be major because climate change is producing climatic hazards. So each intensity, extent, duration is associated to a value, to points, and intensity, time extent, time duration, time possible adjustment if needed, is producing a number that is the impact factor of the criterion, PK. And this is an example where we have a different criteria. Each criterion has an intensity, an extent, a duration, plus eventually an adjustment, intensity, time extent, time duration, time adjustment, determines the impact factor. In this case, you see that greenhouse gas emission has a very high impact factor, 75. And so that when we are defining the weight of the criteria in the category, simply you have to add the impact factors of the criteria in the same category. Like here, 31 plus 25 plus 22 plus 27, result is 105. And then the weight of each single criterion is its impact factor divided by the total sum of impact factors. So for instance, it's 31 on 105. Result is 0.30, so 30%. So this is the way how the weights are set at criteria level. When we move at category level, at this point, we have, we move to the category level. At this point, how it works, basically, you assign a priority score directly to the different categories. So what is the importance of water infrastructure in regard to water consumption, in regard to effluent management? The priority range from 1 to 5. 1 is low, 5 is maximum. And so in this way, again, you are able to set the weight of the different categories. And the same happens for the issues here. So that, again, you define for each issue what is the priority, you calculate the total, and then the priority of each single issue on the total is defining the weight of the issue in the system. This is not 1,005, it's 100%. This 5 is a percent. So it is the city, the region, for instance, that sets the priorities, because the priority is something local. So it's up to the user of the system to decide the relative importance, for instance, of the different issues. So here we have a very also political influence, because when you set priorities, you are taking a political choice option. But of course, your choice is depending on your local context, on your local priorities, or your local urgencies. So each user is defining, in our case, in our project, is municipality is defining its own set of priorities for the issue level, or priorities for the category levels, and also the cities are deciding if an adjustment factor is applicable to the criterion level. Concerning the scoring, so for instance, we start from the category level. This is a category, it's a category, it is the water consumption category C2. There are, for instance, 4 criteria selected by the municipality. 1, 0.5, 1.3, 0.1 are the scores calculated in the normalization phase. These are the weight defined, and then you just have to calculate the score times the weight for each criterion, so that you have a weighted score. You sum the weighted score, and you have 0.73 is the score of the category C2, water consumption. And then you will calculate the score of the issue, where the category water consumption, that is in red, has been is present. So you have other 2 categories: water infrastructure, effluent management. You have the score, you have the weight. Again, you can calculate the weighted scores. You sum the weighted scores, and you have 1.3. 1.3 is the score of the issue C, water. And in the same way, you will have the scores of the different issues. Each issue has a weight. We have defined them before. Then you have score times weight, weighted score. You sum the weighted score, and you have 1.8. It is, for instance, the level of sustainability of this neighborhood with regard to the benchmark, weight, and criteria that you have decided to use. Also, these steps are performed using a web tool that will make it very easy to do, so that in the end you get the final score. And so you have an output with the scores of the different issues. This list are the KPIs, but I will come to the KPIs in a minute. In the SESBA-MED project, the system has been applied on several different neighborhoods to identify the best retrofit options. And I'm going to tell you about the use of the tools in this decision-making process in the second part of our meeting. The tool has been very useful for cities, for instance, to evaluate the actual performance of a neighborhood, to fix performance targets, and to evaluate possible alternative scenarios for improving the sustainability of the neighborhood. This kind of process that I described you for the contextualization phase, the selection of criteria, fixing the benchmarks, and then fixing the weight priorities. This is something that can be done through a participatory approach. So if it is only the municipality or someone, the decision making, that decides what are the criteria to be used, what are the priorities, what are the benchmarks, this is a top-down approach that is not really a good approach. In our projects, we are, let's say, pushing for a bottom-up approach, so that through we name them project committees. Here you see a couple of pictures. So through this participatory approach, the selection of the parameters has been public criteria. Also, the definition of benchmarks and also the priorities were fixed through public consultation, so that in the end, the assessment system really reflects also, let's say, the priority of the community living in the neighborhood. And these are images from Udine in North Italy. It has been also very, very interesting to, let's say, compare the scores with the perception of the inhabitants. So that many times it happens that the inhabitants they could have a different perception of the sustainability level with regard to a calculated value. And of course, probably the reality is a mix of the two. Sorry, the system may be used on small neighborhoods or huge neighborhoods, like this one in Marseille, in France. Each partner used the system for assessing the current state of the neighborhood and to define the concept. And this is in Lyon, in France. In Barcelona, we had an application to a small urban scale, so also on a cluster. In this case, it was a block, and where there is the Agency of Housing of Catalonia. And in this case, the tool has been used to identify the strengths and weaknesses of this block, and also to define a pilot concept for the improvement. Another case study has been always in Catalonia, Sant Cugat del Vallès, where the municipalities applied the system on a huge urban area. They were evaluating two possible scenarios. And so for each scenario, they have evaluated the results in relation to the targets fixed by the municipality. So as you see, these are very powerful tools for supporting the decision-making of a municipality in urban retrofitting. When you are at urban scale, the complexity of decisions is very high. The variables are many. The stakeholders involved are many. So it's very, very complex. So you need a multi-criteria system like this one to support your decision-making process, providing objective, reliable information to understand the situation, to understand which scenario can have the best impact, of course. We had also an application in Greece, in the SESMA-MED project, and also in the Sustainable Med Cities project, the NECBC MED one, the current one. In reality, we are using the systems combining the building and the urban scale. So we ask the different municipalities to prepare a local version of the SB tool for the buildings and SN tool for the neighborhood, and then to select a neighborhood and to select in the neighborhood one or more public buildings, and then to define a concept for the retrofitting of the neighborhood that is creating a synergy between the building and the neighborhood scale. Because, of course, the building by building approach is not winning. You could have a bad building like a school that was built in the 70s, is very weak. You can't improve it too much. Maybe you should demolish it or reconstruct it, but maybe you can't. At this point, maybe you can exploit possible synergies with buildings that are in the same neighborhood that maybe can transfer renewable energy produced by solar panels or PV panels, or create also synergies not in the energy field, it could be in the transportation field or in the water field or whatever, so that the building can really reach a higher performance with this urban scale approach. So in this case, each partner here works on different scales, always defining through the analysis the current state and identifying the weak points and then finding the best retrofit scenario. Before opening the floor to your questions, I hope that I try to be as much as possible clear. I know that is a complex topic, but if we go to the platform. This is the beta version of the assessment system. Basically, and you, if you want, if you decide to use this assessment system in your project, you will have credentials to enter in this system. You can at this point open any of the modules. Just a second, I have to log in. Okay, here we are. So, for instance, one time you enter in the system, here you are able to visualize the available generic frameworks. We have here the ones produced in the SESMA-MED project, for instance, but we also have the new ones produced in the Sustainable Med Cities project. SMC stands for Sustainable Med Cities. For instance, here we have the SN tool. So I can open the SN tool, and then here I can visualize all the different issues. I can open any of the issues, and I can visualize the categories. I open the categories. I can visualize the criteria with the intent. I can open each indicator, each criterion here, and I can visualize the name, intent, indicator, unit of measure, the assessment method. And we foresee the possibility to add languages to, let's say, allow the use of the system in the local language. So we'll have versions in Greek, Spanish, Italian, English, and so on in SBC-MED. Now it's available the English version. So this is the, let's say, the translational level where you can visualize the different generic frameworks. I can open one that has the translation. So for instance, in this case, I can open a card, and I can immediately, you see, change the language of the system. And here you also find the benchmarks for score 0 and score 5. These are just reference benchmarks. This is just guiding values. In the moment you will contextualize the tool to your local context, you have to verify if those values are valid or if you have to change them. So in this part of the platform, it's possible to visualize the content, all the categories, criteria, indicators in the system. And then we move to another part here. In this part, you can carry out the contextualization. For instance, you can decide to produce a new local tool. You select the source, the generic framework that is producing it. So for instance, we can use the Sustainable Med Cities SN tool for the neighborhood scale, and we call it, for instance, SN tool, I don't know, Barcelona. Okay, now we have the SN tool Barcelona here. And now we can start the contextualization phase. Now we are at level of issues. Here you see the priorities. Each issue has priority 1. I can modify them as I want. Immediately, the system is adjusting the weight of the different issues following my indications. Now I can open an issue, and I can visualize the categories. Again, here I can change the level of priority of the different categories to assign the weights. This evaluation, use of land, green urban areas, biodiversity ecosystem, or also closing the priority levels here, this should be defined through a participatory process. Okay, organizing meetings, maybe exchanging with the inhabitants of the neighborhoods, this should be co-created, should not be a top-down approach. So after
Can I ask
defining,
some,
yes, please.
sorry, can I ask something about, as you mentioned, how to input the priority level, as we can say, you mentioned that we can change it, like in your example, you have used 2, 3, etc. Do you believe that this kind of numbers are can be decided through the co-creation method, as you mentioned, efficiently? How can I say? For example, maybe some of these categories should not be included per the participants' point of view. For example, the lowest is 1.
No, it's possible. It's possible to eliminate a category in the moment you are not activating here. You are not activating criteria. If I can open any of the categories here, and you can visualize the criteria inside them. So
I have to deselect the criteria in order to have the category.
Yes.
Okay.
Yes. And this is the second exercise. So when you are inside the category, like here, we are inside B2, here you decide which parameters you want to include or not. And also again, here you can introduce those impact values that we have calculated. So it was the intensity, time, the duration, time, the extent. If you want to use, let's say, a more objective approach. If not, you can just have another co-creative approach. You can decide just to use 1 to 5 again priority, and you can assign here the different priorities. It's we suggest we have defined this approach for this level, so the level of criteria that tend to be more objective, leaving let's say more subjectivity to the higher levels, like the categories and the issues, where it's more easy also to manage those co-creation approaches because it's more simple. In the case when you are at a level of the criteria, maybe you find several criteria in the same category. It could be more difficult to understand that how much one single criteria is more or less important than another one. It's much more easy when you are comparing categories, or more easy totally with the issues. So
yes,
here
because we don't really have the numbers for some of the criteria, and some are really not so characteristic per area. For example, some municipalities, etc., maybe not have the increased knowledge for one of these criteria and the impact in order to be included. So in this case, we could reduce it and remove it for our selection and go forward with all the assessment process.
Yes.
And
sorry.
I wanted to say, can we, because you mentioned that either the impact should be either from like prioritization from 1 to 5 or given number. Should we, I know this is not really a question that could be asked, could we like mix these two cases? For example, in one criteria, we may have the exact impact or the exact percentage, but in the other one, only the priority.
Yes. You can mix, but you must use the same approach for the criteria in the same category. So, if, for instance, if you have the impact values for the criteria in this category, for instance, you can write it 35, 45, or whatever. In the case you are in a category where you don't have maybe the impact for any reason, so here you can use 1 to 5. But the important is use 1 to 5 for A1 to 1, A1 to 2, to 3, to 4, to 5, not mixing the two range of values for the criteria.
So the value must be the same, like the range, not the value, sorry. The range be the same. And
yes, the range,
the same system should be used in order to have to produce the same kind of
Consistent.
value for the priority, as you can say. Yeah.
Yes.
Okay,
Yes.
understandable. Thank you.
No, you're welcome. And then if you click on these three bars, it opens the benchmarks. So here you can write the value of the indicators associated to score 0 and score 5. In this case, for instance, is the viability of urban areas. It's a percentage of green areas on the total of the neighborhood. And so here you should write what is for you the level 0, what is should, so the minimum acceptable. This could be, for instance, a urban standard, and what could be the ideal level. But this is defined locally. So now we are defining some guiding values that you can use, but you must always check if the guiding values is the right one for your specific, of course, municipality. So this is the part of the tool that is used for creating your local version of SB tool or SN tool or SC tool. So for buildings, neighborhoods, or cities, you define the priorities, and from priorities comes the weights. You do select or deselect the parameters that you want to use, and you fix the benchmarks here. And then you have the final stage. The final stage is the assessment, where you can add new assessment, selecting the tool that you want to use. I open one complete assessment. At the end, you get this kind of result that now you are used to. So you get all the scores for the different issues, the weighted score, the total score. Then you can visualize also the score of the single categories. And of course, you are able to get those scores because in the evaluation, you have introduced the value of the different indicators. For instance, we are now in E. It is one of the issues. E1, category E1, category 2, E3, 4. Let's take E1, and then you have again the intent, indicator, assessment method, and here you have the benchmark. Score 0 is 10%. Score 5 is 50%. You write here the value of the indicator that you have calculated. So you remember the normalization function. So introducing the value of an indicator, you get the score. And you can also define here a target score. So what is the ideal score that you would like to reach? No, sorry. What is the ideal value of the indicator that you would like to reach after the intervention? So after the retrofit of the neighborhood, let's say, I don't know, 45%, then it shows you how far you are from the target score, showing the actual score, and then you get the weighted score. It is the score time the weight of the criterion. So you can follow this kind of assessment, introducing the value of each indicator. We have also studied the possibility to introduce GIS data. For instance, these are GIS data of a municipality. For instance, now I am importing the territory of the municipality, belonging to the municipality. It has a strange shape. This is a municipality, the land of a municipality. I can, for instance, import the green areas in this territory. I can import, for instance, the roads, and I can import the footprint of buildings. Here we are. Buildings are not really visible. Okay. Here we are. And you see that automatically the system is able to calculate some indicators that maybe could be difficult to calculate by hand or with the other systems. And clicking update assessment, those values are imported in the evaluation that I opened. So that this, for the city scale or urban scale level, is something very, very, very useful. And if the municipality has GIS data available, they can be connected to an indicator select, and then the municipality is able to calculate the value of indicators automatically. It's really very, very useful. And so at the end, when all the indicators with this icon can be calculated using the GIS module, and then one time you have completed the introduction of all the indicators values, you can get the final results, and you can also export in an Excel file all the different data. This is something new because in SESBA-MED we didn't have this web tool. In SESBA-MED we were using Excel files, and so it was a continuous, let's say, issue to deal with the macros in Excel, because this selection of criteria was really complicated to be managed in Excel, hiding or showing rows and so on. In the new NECBC-MED project, we have defined this web tool. In reality, the deliverable is coming in some months, in March. This is the first beta version that we are providing to the partner cities. We have 3 cities in NECBC-MED, that is, sorry, in SESTEMA-MED cities. It is Sousse in Tunisia and Irbid in Jordan, and a small city in Lebanon, Muqtara. But it's a very important step ahead, because it makes a really usable, easy to use this system. And so basically, this is this is the overview of the tools and the methodology, and everything is described in a deliverable that, of course, we can provide you. Is this one? It has been already published. This was in this deliverable has been published at the end of September. In this document, the first part is what we changed with regard to the SESBA-MED system, and then starting from the chapter 3, you find the description of the methodology. I just show you with the description of all the steps, characterization, normalization, aggregation. Here you have everything I showed you through the slides is described step by step, so that you can go through the methodology, the normalization functions, etc. The weighting system, priorities, how it works. So it's a sort of manual, but it is more easy than you can imagine, maybe. And then here in the second part of the document, you find the description of the generic frameworks. So the SB tool, the SN tool, and the CT tool, where you have, first of all, the list of all the different criteria for each of the different generic frameworks. This is the building scale, for instance. And then criterion, per criterion, you have the tables describing the assessment methodology, the indicators, so that is explaining how to proceed for verifying the different indicators. It's quite a big document because these are more than some hundreds of indicators used in the whole system. Any question?
So thank you very much, Andrea, for your presentation and what you have shown with us today. I have a question about the platform and what you showed us, because I noticed that you were logging with your credentials.
Mhm.
So I guess we have to create an account, etc. Does the account have different functions? For example, if I create an account as a simple user, would I be able to see what you were showing us today, or should I have something different, maybe not so many options?
Yes, we have, let's say, well, you now, my account is the administrator level, of course. But in reality, we foresee 3 different credentials. One is administrator. Administrator is the only one that is also able to modify the generic frameworks. Because the generic frameworks are like the standards. They are the result of the different projects. So if it's possible to modify generic framework, but it has been agreed among the partners, among the ones contributing to the system. The second level of access is for the ones owning, managing the local tool. So it could be the level of a municipality, the level of an agency, the level of a region. So the organization that is carrying out the contextualization and is defining the tool. The third level is the assessor. The assessor can be a professional, can be whatever, an engineering company, an architectural firm, is the one that has to calculate the value of the indicators and to put the values in the system. They should not be allowed to change the assessment system. They just have to calculate the indicators. So the 3 levels are transnational, administrator, generic frameworks, then local owner of the tool, the city, the region, whatever, and then the third, the assessor. The assessor is the one that has the more limited number of functions. It can basically just use the system for introducing the value of the indicators. It can't modify neither the local tool, neither the generic framework, of course.
Yes, so for example, in our case, in our project, the SEACAP for SDG project, and the selected municipalities that we're going to help assess for in regard to their SEACAP and their energy efficiency with the help of the external expert, we can, for example, the municipalities or the external expert for the municipality that they are working with, they can provide the data to level 2 or level 3. Level 2 first. Yes. Level 2, and then have an external someone else to do the assessment at level 3.
Yes, of course. An expert can support the municipality in the preparation of the local tools, supporting the selection of the criteria, supporting benchmarking, because you need to have some knowledge about regulation, standards, and so on. And by the end, the final responsible for the local tool is the public authority. This will be the tool of Barcelona, Athens, whatever. Of course, in the assessment phase, when you are applying the tool to a specific neighborhood, building, or whatever, you can have also more than one assessor, more than one expert that is providing the data on mobility, on green areas, of energy, on whatever, but they are at this point just applying the tool. They can't modify it in the assessment phase. Of course, the system is open, because maybe during the assessment phase, you realize that you don't have the data for calculating that indicator.
This is possible in our case a lot of times, yeah.
It's usual. At this point, what you do? You are going to modify the tool. So maybe in a first step, you decided to include that criterion, but at some point you realize, no, it's not possible to calculate it. We don't have the data, or the data are very poor quality. So in any moment, you can decide to deselect the indicator and to modify the tool. So it's an optimization that is in parallel with the assessment. Of course, as I will go to explain in the next part, when you are composing your local tool, one very important step is the immediate identification of the data source for the indicator.
Yes.
So in the moment you decide to include this criterion, do you have the data to verify it or not? If you say yes, okay, include it in the local tool. If you start with many doubts, maybe no, we don't, exclude it. So this is something that is already anticipated, but you never know. Maybe during the assessment, it's possible that your assumptions were wrong. When we prepared, for instance, when we prepared the tool for the city of Torino in SESMA Med, it has been a very interesting multi-level governance horizontal exercise, because the department participating in the project was urban planning. But at a certain point, we had to prepare the tool for the city. So the department organized several meetings with other departments like energy, building, green areas, mobility, etc. And they were asking questions. Okay, we would like to calculate this indicator. Do you have the data for this kind of evaluation on mobility or on green areas? Do we have the consumption of the buildings or whatever? Discovering the availability of data that was not well known. And this has been a very interesting exercise to optimize the sharing of information and data among different departments, because this kind of tools that are addressing different topics or issues together, because it is an integrated, holistic approach, they force this integration among data departments. It's really something very useful to have those administrations to make a step ahead in this field.
Yes, because as you mentioned earlier, in order to have the whole view, we need to have the data from different areas. So this is pretty much difficult regard not even municipalities, regions, or selected areas as well. So thank you very much. And I have another question. You mentioned that you are now using, I think, JS. Well,
yes, yes.
And how was it was integrated in the platform? I didn't get that.
It is a module integrated in the platform. So basically, each indicator is demanding for data.
Yes, I saw that. I saw the graph that you showed based on the region and on the specific area. What I'm asking is, this was integrated within the platform, so the user doesn't have to select another source for information. All the information is located in the platform. No,
the information, let's put it in this way. The city usually, if they have some GIS information in the format of GIS files. There are different kind of formats, and the information can be about footprints of buildings on the roads, green areas, or whatever. So basically, when you are going to calculate an indicator using the GIS information, you just have to link the indicator with the right file.
So the municipality has to have a file to upload. Yeah, okay, that's what I was asking. Yeah, okay.
Yes. In our case, we have done also an evaluation about how much are available this kind of files in municipalities, and usually big municipalities they have. Small municipalities, it's quite rare, or maybe they just have the information, some topics, but the number of topics addressed by the GIS file is very limited. Big cities like Torino, they have everything, of course, but much smaller cities, no. This could be an issue, of course.
Yes, that's understandable. Thank you very much, Andrea.
I forgot one last thing. Sorry, is this one. Basically, if you remember, I told that in each local version, you must keep a set of key performance indicators that are mandatory. So you must include them in your set. So we have developed the concept of the passport in the project. So in the moment, for instance, you are assessing a neighborhood, you will get two different results. One are the scores, but the scores, they have a local value because the scores are based on your benchmarks, your weights, your selection of criteria. So you can't compare, for instance, a 2.5 score of a neighborhood in Barcelona with a 1.5 score of a neighborhood in Athens, because the two scores are based on different benchmarks, weight, a set of criteria, but they have the same meaning. It is a common language, so you are able to understand the meaning of this. If you are in Barcelona, the meaning of this 1.5 score in Athens. It's something that can facilitate also the share of best practice, and a common language has been established. If each city is using a different scoring system, a different weighting system, everything different, this would really be an issue because you will have a lot of confusion. But to allow a direct comparison of the performance in two different cities, we can use the KPIs, because the KPIs are much more detailed in the calculation process. So we can assume that each municipality, for instance, calculated the indicator in the same way, so that you can compare the indicators of two different neighborhoods in two different cities, not in terms of scores, but in terms of values. So for instance, you can compare the permeability of land in terms of percentage of permeable area, or you can compare the CO2 emissions per inhabitant if they have been calculated in the same way, and so on. So beside the scores, there is another document called the passport, named the passport. The passport is like, it's represented on the page on the right, is the list of the KPIs and the values of the KPIs, so that you are allowed to compare passports of different cities to see how they are performing, not as scores, but as values of the indicators. And also, the passports are useful for aggregating the performances, because the key performance indicators are the ones linked to the global challenges, to the SDGs. Maybe we want to know how much we are progressing in the Mediterranean, let's say, through the contribution coming from the different municipalities. Again, if you use different unit of measures, different indicators, it's not possible to measure how we are progressing together. In this case, using the same indicators, it's possible to aggregate the values, and we can also have an indication about how much we are progressing. This is what there is behind the key performance indicators. They have a dedicated deliverable, and also in the training material we are producing. You know that another important component of our project is an e-learning system, and we have a training material that explain in detail how to calculate the different KPIs. The additional indicators, the not KPIs, they are described in a more generic way. KPIs are much more detailed. And so this is something that is useful for really understanding the practices implemented in other cities to learn, to exchange, to cooperate. So this is what is behind the idea of the passport.
Okay, Andrea, thank you very much, and for showing us the passport and the KPIs and how they are used for the different cities. And as you mentioned, that some cities cannot compare, but they can use the same KPIs, etc. Yes. So, is there any other question from the participants?
If not, we can have a little.
Yes, we can have a break. Yeah.
A break, and then we can move on the second part. That it is the explanation about how to use those tools in a decision-making process. That is the core, in reality, of our project, because the assessment system is just a tool. The final objective is in reality, is to raise the capacity of municipalities, in our case, to deploy effective action plans, effective measures, they have to take decisions. So this is the final objective of the project. The tool is supporting, let's say, the process, but the final objective, raising the capacity in decision making. So in the second part, after the break, I will illustrate you how the decision making has been defined in a model and how the tools are used, so that you will have a complete idea about what we are doing. You can decide if this could be usable in any other city in your project.
Okay, Adela, thank you very much. So maybe we should be back in 10 to 15 minutes, and if it is possible for you, and then we can continue with your. Okay, thank you very much.
Good, thank you very much.
So I believe everyone has logged in, has logged back in, and we can continue if you are ready.
Yes.
For the second part of your presentation.
Okay. As I told you before, the second part is focused to illustrate you the decision-making process based on the use of the SB tool, SN tool, and SC tool. Basically, we have 7 phases in the decision-making methodology, starting from an initiation and ending with the 7th step, the retrofit concept. That is the final goal of the decision-making process. So we want to identify the most suitable, optimal concept for the sustainable retrofitting improvement of a neighborhood and public buildings in the neighborhood. So the first phase, initiation, is a preparatory phase that basically foresee the identification of the urban area to be studied, the public buildings to be studied, what are the target groups to involve, the stakeholders, and also the setup of a working group, the one that will carry out all the different stages in the decision-making process. So the expert, let's say, the team of experts. We have defined a testing protocol. Sorry, a testing protocol for the decision-making model, so that the decision-making model has been, let's say, disaggregated in a series of tasks that will guide the municipalities and the experts in the correct use of the decision-making process. Each task has a number and description, who is the responsible, and also we have let's say, a connection, a link with the different deliverables that are used in the decision-making phase. The first, of course, step is to identify to select the urban area that will be studied, and the buildings, the public buildings in it that will be also studied. It is necessary to clearly define the physical boundaries of the urban area. The boundaries can be defined on the basis of geographical proximity of buildings, the ownership, could be social housing neighborhood, for instance, social economic context, it could be an administrative boundary. Usually cities are divided in sub-administrative areas, or maybe the period of construction or the energy supply infrastructure. It's up to the municipality to decide the principle used to set the physical boundaries of the urban area. And here you have, for instance, the boundaries defined by a city. There is a red line here in the picture that are the physical boundaries, so that you really have to draw the line. And in this green, these buildings in green, 1, 2, 3, are, for instance, the public buildings also included in the study. Of course, in the project, we asked the cities to provide an explanation about why they have selected that area and those buildings, and what is the rationale behind it. Okay, so always part of this step is to set up a working group, the team that will carry out all the tasks of the decision-making process. And there should be a coordinator of this working group that will be the main interface with the municipality. And always part of the initiation phase is to collect information about the urban area and the buildings, to describe them. Could be physical properties, characteristics, or other. And for each of those tasks, we have prepared a template that has to be filled. It's also important in this phase to identify the stakeholders. Who are the stakeholders to be involved in this decision-making process? It's important to identify them since the beginning, because we are promoting this co-creation approach, a participated approach. So the stakeholders are the ones that will participate in this co-creation. They can support the municipality in identifying the targets, the weaknesses of the neighborhood, of buildings, and also to take into account multiple approaches. Typical stakeholders can be the various departments of the municipalities, maybe local agencies, other local authorities, experts, service providers, waste, water, waste collection, water, energy, etc. Interest groups, maybe associations of residents, and maybe also external parties. Here you see banks, funding agencies, because in this process we stress when the municipality is called to prepare a scenario, we stress also to identify what could be the funding sources for the implementation of the scenario. That is a very important component of the study. So this is the first step, initiation. Then we have the preparation. In the preparation, basically, we are going to carry out the contextualization, in this case of SN tool and SB tool, because the spatial scales addressed are the neighborhood scale and the building scales. So here we carry out this work to produce the local versions of SN tool and SB tool. Also, in this case, the decision-making process is described in a series of tasks that you can recognize following what has been explained in the first part of our meeting. So you have to prepare a local version of SN tool, SB tool. So you have to select the criteria, you have to select the data sources for each criterion, you have to fix the benchmarks, you have to assign the weights, and of course, you have to organize workshops to discuss these selections, to make them public. In our case, we call them PGS because we are, let's say, adopting what is the typical approach of the participatory guarantee systems. So it means that these are processes participated by the different stakeholders that guarantee to save all the key interest in the process. So this has been already explained. This is the moment to select the criteria, to fix the weights, to fix the benchmarks, to prepare the local version of SN tool and SB tool. The selection of criteria is very important because basically here you are deciding what topics you want to include in the assessment and which one you want to exclude. The topics not included will not be included in the retrofit concept. So it's really very important, this selection. Also in this case, there is a very strong political component in this defining what has to be included or not. And also in the moment you are setting the priorities, the weights are the priorities of the municipality. What the municipality is considering more or less important, what should be trust in the preparation of the concept. So this is a phase where this participatory approach is very important. And as we were discussing before, you know that each criterion in the assessment systems is requiring data to be calculated. So it's very important here to identify immediately the sources of the information needed to calculate the indicators. Because if you verify that this information is not available, also if you would like to include a certain indicators, it will be useless. So you should exclude the indicators from the tool. But in any case, you have identified a gap of information that should be filled in future. So it's a matter of availability of data and also quality of data, because of the reliability, credibility of an assessment with those tools is also linked to the fact that the information used is valid, is good information. It's important to identify data, data providers, data sources, and as we were discussing before, the availability of GIS data is something that could be very useful for accelerating the data collection process. The providers of the information could be very different, could be regional, municipal departments, public agencies, statistical offices, building owners. You can find information through certifications, utilities, maybe you can also use some public free sources like OpenStreetMap or Google Earth. Maybe it's possible to carry out on-site inspections, or you can find database maybe produced by other research projects. So it's the data sources can be very various. And in this phase, let's say the process suggests to organize a workshop to discuss the selection of criteria and weight assignment. Third phase is diagnosis. The first thing that you do if you don't feel well is to go to visit a doctor, and the doctor visits you and provides a diagnosis. What is the current state of your health? This is the same thing. We are using SB tool, SN tool, to understand what is the current state, health of the neighborhood and the buildings that we have included in the study. So we want to understand what is the current conditions, because this is very important to identify the weaknesses and also to identify the potential to improve. Also to understand the gaps in awareness and the opportunities for actions, because they are not always really clear, and also to identify possible synergies that can be exploited to improve the situation. So basically, this phase is very important because it's the base to fix also the targets to improve the situation and to create the basis for developing the scenarios, identifying the weaknesses. Again, there are a series of specific tasks to be carried out. In this phase, we are going to apply SN tool to the neighborhood. We are going to apply SB tool to the buildings, taking a picture about the current state. So we are going to compare the performances with the benchmarks, values, and we are going to assign scores to the buildings and the neighborhood. At this point, it will be possible, for instance, to rank the criteria in the tools, in SN tool, SB tool. Here you have a table with only 7 criteria, because it would be possible to have in a slide maybe 40 criteria. But the idea is that on the base of the evaluation, you assign scores, and the scores tells you where the weaknesses are, so that you can rank the different criteria from the most negative to the best ones. Doing this ranking, you can immediately identify which are the weaknesses in the neighborhood. For instance, in this example, the weaknesses are the scarcity of green areas and the high concentration of PM10, so very bad quality of air, and also the energy consumptions and the waste management are just the minimum acceptable. The public transportation in this case is good. So through this ranking, you immediately are able to identify problems, issues. Of course, these are calculated values, and we suggest to also carry out surveys, interviews among the inhabitants in their area, because maybe it's possible to identify sustainability issues that are not evaluated through the indicators. So the combination of this qualitative evaluation, so the interviews plus the quantitative evaluation scores, can give you a complete picture about the state of the neighborhood. It's also important in this phase to analyze the current state of infrastructures, basically energy and water. So to understand, for instance, concerning water, if there is a sufficient provision of water, if the water is of quality, what is the level of losses, what is the level of water treatment. And concerning energy, it's important to understand if there are weaknesses in the energy infrastructures, the potential of use of renewable energies in this case. And in our in the methodology, we described some let's say methods for evaluating the current state of the energy infrastructures concerning the heating and cooling networks, the electric demand, the evaluation of the energy potential of renewable sources. At this point, you of course carry out this analysis for both the neighborhoods and the buildings included in the study. So of course you will use SN tool for the neighborhood, SB tool for the buildings, and also in this case you can organize a workshop to understand the point of view of inhabitants, occupants of the buildings, or the inhabitants of the neighborhoods. And what the final result will be a SWOT analysis that is the base for the definition of the scenarios later, so that through this diagnosis you can identify the strength of the neighborhood, the weaknesses, but also what are the opportunities of improvement and what can create problems, threats in future. And then basically the final output will be a summary report that can be also in this case discussed with the stakeholders. The fourth stage is the strategic definition. Okay, now we have select the area and the buildings. We have defined the local tools through the contextualization of the transnational versions of SB tool and SN tool. We have prepared a SWOT analysis. We have carried out diagnosis. We have identified the weaknesses, the strength point, the opportunities. Now it's time to proceed with the identification of the best package of measures to improve the sustainability of the urban area. What we name scenario. The scenario is basically a package of measures that can be different kind of measures. You have to, for instance, add a couple of bus stops. You have to improve the permeability of land. You have to improve the quantity of urban areas. You have to improve the thermal insulation of buildings because you want to reduce the energy performance. You want to improve the energy performance. So this is our packages of measures. But what are the best ones? What is the best package of measures? In the strategic definitions, basically, the municipality is going to define the sustainability targets, but also to identify what are the constraints and the restrictions that will limit the number of possible solutions. Again, several tasks to be performed. And the first step is to define targets. If you remember when I showed you the web tool, we were evaluating the score for a criterion. There was the possibility to introduce a value of the indicator as target. So in this phase, the municipality is going to define criterion per criterion, what is the target to be reached. And of course, the targets should be, of course, achievable and realistic, not just dreams. For instance, following the example, we have identified in the diagnosis 4 criteria that are critical to our negative And on the right, in green, you see the target scores. So the municipality intend to improve the performance of the building for green areas from -1 to 1, PM10 from -1 to 1, their access to solid waste and recycling collection points from 0.4 to 1.5. So these are target scores. And of course, as you know, the target scores are related to a target value of each indicator. So these are the values that will guide the preparation of the scenario. So the measures that have to be included in the scenario are measures that will allow to reach that score, that target value. And as you know, these are verifiable target values because are indicators, so you can calculate them. Constraint, you can't do everything you want, of course, because there could be legal constraint, technical constraint, financial constraint, environmental constraint, and maybe restrictions that are based on the willingness of stakeholders, opinions of the stakeholders. Legal constraints could be linked to building codes, for instance, or cultural heritage protection. Maybe in a certain area, you can't install PV panels on roofs because it's a cultural heritage area, and this is forbidden. So in your scenario, of course, you can't include PV panels, or there could be financial constraint. That could be the cost of the solutions, and so on. So also in this phase, it's possible to organize consultations, workshops, to let's say mainly to define the targets for the retrofitting project. So what are the targets that the community would like to reach? And now we have to define the scenarios. This is a very challenging step, because in this phase, different scenarios will be defined, and then one of them will be selected. Scenarios are alternative packages of measures. And so this is a design, a planning exercise to be carried out. Again, we have tasks specific to be carried out in this phase. So we can have scenarios, so packages of interventions that foresees interventions on physical interventions, technical solutions, but there could be also soft interventions that could be something about knowledge, awareness raising, participation, etc. Of course, it's important to integrate both of these kind of actions. This is a co-creative exercise, because the retrofitting scenarios should be developed in cooperation with the stakeholders. And of course, all the buildings should be considered as a connect global system, combining this building scale and urban scale approach. And of course, intervention should address the weak points identified in the previous steps. So intervention could be related to very different fields like energy, water, use of land, mobility, health, social economic issues, and so on. In our approach, we suggest to start from energy. So to consider energy as the priority field. It is for many reasons, mainly in this moment, in these hard times. Energy is related to CO2 emissions, energy is related to the scarcity of resources, the package should start from the identification of the best package of measure to improve the energy performance, and then moving on the other thematic field, so non-energetic interventions. To define a scenario starting from the energy field, it's important to identify and optimize the possible intervention urban level and building level. Then you will add the non-energy related interventions. Then it has to be analyzed, the possible business models, financial schemes, and then you have completed the scenario through a validation. Of course, the starting point are the weaknesses identified in the diagnosis phase and the targets set in the previous stage. And of course, this is an iterative task where the team analyze the result of a scenario up to its optimization. SB tool, SN tool are again the tools used to understand what kind of results each package of measures can achieve. So it's a way to measure how much the scores are improving with regard to the diagnosis phase. We also realized that it's almost impossible to have an automatic optimization. So the dream, I push a button, I get the scenario. No, this is impossible, because in a case like this one, in any case, you will be limited because you should use a repository of solutions. Maybe the repository is not updated. It may be not all the solutions available in your context are in the repository, and it may be the automatization of the packages are also limited in the number of variables that they are able to consider. So here it's a really planning and design exercises. We suggest to use let's say an approach based on filters. If you take all the possible solution that you can apply in the neighborhood or the buildings, you can filter them considering the constraints and restrictions, and then the number will be more limited. Then you will take in consideration the solutions that are addressing the diagnosis results, the weaknesses, and this will be also reduced. And then you have to apply a logical application. And then you have also to understand what kind of financing solution could be applicable. So that this is another filter, because it's nice to define an optimal scenario, but if you don't identify how it can be implemented in practice, so what are also the financing or the business models necessary, this will remain just an academic exercise, but will never reach the reality. So basically, you have to exclude all the interventions that are not suitable, not applicable for the buildings in the urban area, as I will see. You have to focus on the solutions that can improve the performance in relation to the weak points and the targets set by the municipality. And then you have to apply a logic of application of the interventions, starting, of course, from the energy. So first of all, you should start to create your package of measures, starting from the ones that allows to reduce the energy consumptions. So it means to reduce the energy needs. Then the interventions that can improve the efficiency of the energy networks, and then the use of renewables. So first you reduce the demand, you improve the efficiency, and then you cover the remaining needs using renewables. And this here you have the interaction between the building and the neighborhood, Okay, so this is the chronological logic. You have, or maybe I lost you. No.
Now we can hear you again.
Okay,
We lost you for 2 minutes.
Okay. So this is the creation of the starting point for. Sorry, I have some. Do you hear me again or no? Yes.
Yes, we can hear now.
Okay, sorry. Okay, again, we can start the creation of the scenario. The energy intervention should follow this logic from consumption reduction to energy efficient supply to renewable. Then you add the non-energy interventions. In any case, for each scenario, you have to identify the possible business models and financing mechanisms, loans, grants, energy performance contracting, co-investment, tax benefits, and so on. And finally, you have to discuss, of course, the scenarios again with stakeholders to identify the best one. Then we have the decision-making phase. Now you have to decide what is the best scenario to be implemented. And again, you will use SB tool, SN tool for this decision-making step. Again, many tasks. So your goal in this phase is to define which among the different packages of measures, what is the package of measures that is the best one for your situation. And so basically, you apply SN tool, you apply SB tool to the urban area, to the building scale, assuming that the intervention have taken place. So what will be the performance, the potential performance after the intervention for the urban area and for the buildings? So you are calculating potential scores depending on the kind of intervention. At this point, you will have, for instance, 3 scenarios. Each scenario is foreseeing some measures. And so you say, okay, the neighborhood after scenario 1, so it's a package of measures. After the implementation of this package of measures, the urban area will have a score 1.3, and the building A 2.1, and the building B, if they are 2 points. And you will do the same for the scenario 2 and scenario 3. At this point, it's possible to rank the scenarios. You are going to combine those scores, 3 scores in this case, for the scenario 1, 3 score for 2, and 3 score for scenario 3. You're going to combine them in a global overall score. You have to decide what is the weight of the 3 scores in your evaluation. For instance, we can assume that the urban scale score is more important than the building scale, and maybe building A is more important than building B because it's I don't know, bigger, or it's historical heritage, or for any reason. So you can do a weighted score. So this is, for instance, the score of scenario 1. In scenario 1, SN tool was 1.3, building A 2.1, building B 2.0. You apply the weight, and then you do a weighted score. So scenario 1 score is 1.4 in total. And at this point, you can do the same for scenario 2, scenario 3. So at the end, you will have the overall scores, and you can rank the scenarios. So scenario 2, in this case, is the best one that allows me to reach the better performance. Of course, the three scenarios have been already validated from the financial and business mechanism because they are feasible. It's possible to implement them in theory. At this point, in the final phase, you select the optimal scenario. You can also take in account expert judgment, not quantified experts, surveys, whatever. So it's not that you have to take this ranking as the final one, but maybe for any reason, scenario 1 could take the place of scenario 2 as the first, if it is the case when you have inputs that are, let's say, indicating the second scenario as the best one. That could be not only quantitative. So the last word is always in the hands of the municipality. The whole process is to produce guidance for a municipality to take the right decision, considering the real situation of the neighborhood and buildings through the diagnosis, fixing measurable targets, exchanging with the stakeholders, evaluating different potential scenarios, ranking the scenarios from the point of view of target, and then taking account also the not quantifiable issues. At this point, one scenario will be selected. And the final step is the retrofit concept. At this point, the scenario is detailed. In this phase, each measure is described, the expected results are declared, the activities and works to implement the interventions are defined, the time scale, a rough budget estimation, the financial scheme to support the intervention, who should be responsible for the implementation, which department, for instance, or agency, what are the partners needed to implement the action, who are the reference stakeholders, and the links of this intervention with future strategies, plans, and programs. So each intervention in the package has to be described in this way. We are still in the detail in the level of a concept. We are not yet planning. We are identifying the interventions, and of course, when the municipality will decide to implement those interventions, there is a very valid preparatory work to support in a very efficient way the planning of the intervention implementation. The cities in our project, as already they did in SESBA-MET, are applying this decision-making process. Of course, these are, let's say, these are tasks useful to raise the awareness of a municipality about the potential use of sustainability assessment systems to support their decision-making processes. This is maybe the most important result. Maybe the final concept will be not really the optimal one. This is an exercise in the context of a research project, but the main goal is to have a municipalities understanding the use of those systems, assessment systems, to take good decisions, to improve their capacity to act, to their capacity to deploy good plans, not only to design concepts, because in reality, the assessment systems are able to support the whole life cycle of a retrofit project, because in this exercise, they are used to define the concepts, to identify the best retrofit package. But in reality, they can be used also to monitor the implementation of the interventions. So basically, you are repeating the diagnosis in different times so that you can really check evaluate, monitor the improvement, a real impact of the intervention over time. It's a very powerful monitoring system. It's a system used for also to validate the plans, the action plans, implementing the concept. So this is the exercise. So in the case you find a municipality that is interested in using the results of our project, this is the package: generic frameworks, a web tool, a decision-making methodology with a clear articulation of tasks, and an e-learning platform. Then it's up to you to shape everything to fit your needs, to fit your objectives. You can simplify the whole thing. You can reduce in few steps the decision-making process. You can personalize, adapt those tools to your specific goals. But the most important thing is really to transfer to municipalities the knowledge of the existence of those tools, and to have them understanding how they can really improve their capacity to act. We have a deliverable, again, 2 deliverables in addition, that are one describing step by step the decision-making process that I summarized in these slides. And we have also a protocol for the implementation of the decision-making process task by task. And for each task, we have also defined templates for reporting the results that are very useful for the documentation of the work process, and also to easily communicate what is expected in each task. In the SESVAMED project, we had 9 tests in different Mediterranean cities. We have improved this process in the new project, and now the 3 cities participating in Sustainable Cities are right now starting this program, this process to produce the retrofit concept. I would say that that's all from my side.
Very well. Thank you very much, Andrea, for your presentation and for giving us an input on this approach. So I believe that it was really helpful in order to understand the different scenarios that need to be followed and how they have to be structured in order to be later materialized in a in a tool, and the process that need to be followed. So is there another question at this time for all of us that are still joined here? I don't think there's a question. So maybe I want to thank you for the presentation. It was really useful, and in order to understand, as I mentioned earlier, how we have to create the scenario, and also how it would be useful to us as a SEACAP for SDG project. In our case, I'm so sorry if I have bad connection. In our case, how to implement it as a SEACAP for SDG project in order to facilitate the first level controller development process that is as part of the municipality, and then as a second level that is going to be implemented in the SouthMed cities to involve specific buildings at a later stage. So I think this is pretty much for it. I don't know if there is another question from the audience. No, the participants don't have anything else. Of course, we will be able to provide them with all your contact info and give them the recording and the presentations as well. And if they also have a question later on while they're trying to use the tool and the platform, we will be able to facilitate the process
By the way, we have, if you are interested to follow, we have foreseen training activities in sustainable made cities that will be delivered to the experts that will carry out the tests, the decision-making process for the participating cities. And it will be online training mainly. So, for instance, if some of the experts in your project are interested to use the tools, etc., they maybe could join this training that will be more specific than today. That I delivered a lot of information.
Yes, you showcase us
yeah.
the whole process.
Yes, of course. But as I told you, there is also an e-learning platform that is we are updating because we changed many indicators. So we have optimized the tools in SESBAMED. We had the first version. After the test, we realized that some parts of the tools were had to be improved. So we did it in the new project. We have the web tool that was not available in the previous project that makes everything much more easy. And so we are going to transfer all this knowledge and tools to the partners through training sessions. So if your partners, your experts are interested, they could join this training, and we can, of course, support you in using them, in providing feedback, whatever is needed, of course.
Of course. So maybe after the session and when we have all the materials, you can send us additional information regarding this training, and we can forward it to the trainers. And since not on week, the week after the next, we will be having also for us a project meeting to involve all the partners. We will be able to inform them and invite them later on if we have the information.
Okay.
In your training session as well.
Yes.
So this is it from our case. Thank you very much once again for joining us. And I believe that the presentation was really useful, and we would be able to use it if one of the external experts choose it for the municipalities, especially in the regions that were involved in some part on your project. For example, I noticed that SUS, there is information, and we have a project partner from SUS, so maybe they could find, yes, we have a MEDREC, the Med Renewable Energy Center, yes. Okay. So maybe they could find a solution, or they could use some part of the information that you provided. SUS
is going to test the system. They are now in the initiation phase. Now everyone is in the initiation phase, so they are selecting the urban area, they're selecting the buildings. They still have to start the contextualization of the tools, etc. And our partner is the municipality of SUS. So maybe your partner could cooperate with
yes,
them.
They can sometimes work with. I'm not sure which municipality MEDREC has chosen, but we can facilitate and see this. Okay. So once again, thank you very much, Andrea, and welcome. Of course, Paola Borgano for facilitating this training and for agreeing to be part of the SEACAP SDG training session. Thank you very much, and I hope we can collaborate again in the future and we can use your tools later on. Thank you very much.
Thank you very much. Thank you to you. Bye. Have a good night.
Have a good rest of the day. Bye.
Bye-bye.